Okay, so once again, complex numbers, looking at them. Okay, remember, it's an extension from the real numbers. Okay, let's remember, if we kind of think about this carefully, we had the natural numbers. Outside the naturals, we had the whole. Outside the whole, we kept going. We get the rational numbers. Inside those, we also had the irrationals. Then you keep going, you have integers. Remember, that's the -3 all the way down, -1 all the way up. All of those comprise the real numbers, right? And then you walk outside that and you get the complex numbers, okay? That's how come for most of college algebra, most of intermediate algebra, I stated, hey, you cannot take the square root of a what? Of a negative, okay? Remember when you try to take a square root of a negative, first off, you try to do it right now on your computer or on your calculator, it's gonna still tell you, hey, you can't do that, okay? Because your calculator deals with real numbers, whereas that's not the case. Okay, so an imaginary unit defined as I is defined as this right here. Okay, that's how we define it. I is equal to the square root of -1. So why is that the case? Well, let's go back and remember that when we had something of the form a times b, we could split that up into the square root of a times the square root of b, right? Remember that kind of like that's hearkening back to some things. So if I had something like, say, the square root of -2, well, remember to make a negative, you have to multiply it by -1. I could split this up into the square root of 2 times -1, which we know turns into the square root of 2 times the square root of -1, which turns us into -2i. That's just a long mathy way of saying, hey, if you have a negative on the inside, pull it out, make it I. Okay? But like I said, you're going to get a little bit more mathy in this class. Okay? You need to start seeing why the things work. Okay? Now, another thing to note. Notice this second one here. Can anybody tell me I squared is always what? It's important, isn't it?
Negative.
Negative what?
1.
Exactly. I squared will always go to a -1. It should make sense if we think of it this way. If I gave you a square root, and we're going to make the square root of -1, how would you remove the square root? What's the inverse of a square root? Power of what?
2.
2. It's always raise it to the power that matches the index. Remember, the index is the little number that sits right here, and we know that's a 2, which we wouldn't put with a square root. So when we raise this to a power of 2, this turns into what? -1. Okay, that's why I squared turns to -1. Okay, so anytime through your processes of doing some of this stuff, if you get I squared, your muscle memory needs to always go to, I don't have I squared, I have -1. Okay, just so y'all know. Okay. We have these right here. You're going to use them again. They're not on your midterm. Don't freak out. Okay. But we do have those formulas. Okay. So you will be doing some more of these again, like you did in the last class. I'll give you a chance to write those down if you need to. So, for any two real numbers, A and B, did you not give a chance? Oh,
No.
here you go, right there. For any two real numbers, A and B, and don't forget, I'm going to download these notes for you later. So if you miss something on the notes, don't freak out. They're downloaded. Okay. For any two real numbers, A and B, the sum of A plus B is a complex number. The collection C, complex, there's your little symbol for it, a little carnival letter. There's an actual notation name for that, but it escapes me right now. Says this. A plus BI such that A and B are both real is called the set of complex numbers. And is another example of a field, okay? A field, which you don't need to know until you take a master's level math class one day, but you all will. Okay? A field is something that you can only perform the operations of addition and multiplication. Okay? That means you can't subtract them. They don't, that just means they're not commutative, okay? Like 2 plus 3 is 5, right? But then 3 plus 2 is still 5. We can switch it. You can do that with real numbers. I mean, and you can also do that with complex numbers, okay? Well, this is also stating this. Hey, if I do 2 times 3, that's 6. Well, 3 times 2 is also 6. So what it's trying to tell you in a very long mathy way, other than this other part here, is really the complex numbers behave exactly like the real numbers you've been dealing with all along. And so you really don't got to freak out. Okay? The same math that worked over here works over here because by extension, it's why you have the real numbers here. You take a step forward, you're now in the complex. That's why they still work. Some things you can't do, but there's some things you can't do with real numbers either. Okay, but that's a definition of a field. Okay, but the number A is called the real part of the A plus BI, and the B is called the imaginary part. If the imaginary part of a given complex number is 0, the number is simply a real number. If the real part of a given complex number is 0, the number is a pure imaginary number. That got wordy, didn't it? We have 3 plus 3i. That guy is your real. That guy is your imaginary. The I is not your imaginary. Whenever it starts asking your homework, what's the imaginary part, don't put the I. You're going to get the little thing pop going, you don't need to use this. The 3 is the imaginary part. Okay? Now what it's saying here is if, say, the imaginary number was 0. Well, look at this. 3 plus 0, I, well, we don't do 0. So that's just a real number. Which is basically saying, hey, every number is a complex number. It's just sometimes we don't see the complex or the imaginary part because it's a 0. Okay? Whereas if you had 0 plus 3i, well, notice once again, you don't have a 0 for the real. So this just becomes a pure imaginary while still retaining the complex number. Okay. That kind of make a little more sense about what it's saying. Okay. Because and I've shown you this before, some of you, if you haven't before, you've all learned how to graph. Okay. And you have a Y and you have an X. Well, you can't graph these. Okay, the same way. Y is now going to become our imaginary line. X is going to become our real line. So using the same numbers before this 3 plus 3i, and I'm using plus, but it can be minus too, right? You can also have -3 minus 3i. Okay, but notice I would come over here 1, 2, 3, 1, 2, 3. Well, that would be the point right here. But that would be the point 3 plus 3i. Okay. And this is called the imaginary plane. You won't have to graph them, but it is good to know. So far, so good. Okay. I don't want to lose you, but like I said, we are going to get a little bit deeper than we did in intermediate. While intermediate is still basically focused on the tools, I want you to walk out of here knowing a little bit deeper math. Because like I said, I don't know where you're going. College algebra was a weird one. Like intermediate, I know where you're going. You're coming here. Or stats. Okay. But here, man, there's a lot of here you might be done, or you could be going off to trig. You could be going to stats. And if you're going to trig, there's probably a good chance you're going to calculus. Going to calculus, you're probably going to keep going up through calculus. Most people don't stop at Cal 1. Some do. They are requiring calculus more for upper double degrees now. Even to become a lawyer to get into law school, they want to see mathematical skills. okay? And we're talking like Cal 3. Because they're saying, hey, if you can do math, you have logical thinking skills. You can think in this XYZ pattern. Well, isn't that kind of what you need to be a lawyer? Also, get into med school. It's really good, okay? Doesn't mean you're going to be using that math, but it says, can you think logically? And that's really what math is. Can you think logically and weirdly abstractly at the same time? Like this is kind of abstract. This is saying there's these weird numbers out there that are imaginary, but we believe in them. Okay? So, continuing on. Let's look at some basic operations. Because these are extensions of the real world, we can expect them to behave the same way. So we're almost in a review of 1.3 now. Okay? Very first lesson I did in 1.3, I said, hey, if you have a problem and it is separated, if you have two expressions separated by a positive symbol, what do you do? What do you do with those parentheses? Just remove them, just drop them, right? And then you can rewrite it. So notice I could rewrite this as 4 plus 3i. But when I drop it, notice it's dropped, but there's a -5 there. So I'm gonna put that -5 there, but then I can just keep the 7i. Now, can I just add everything together?
The ones that are imaginary and the ones that are real.
Yeah, real to real, imaginary to imaginary. And make sure to keep them in the proper form. Remember, the proper form is always a plus bi. Because as weird as that looks, ladies and gentlemen, that is a number. That is no different of a number than the number 3. You know, 3 plus 3i would be a number. If I could give you my age in complex numbers, that would be my age in complex numbers. I wouldn't know what my age would be in complex numbers, but still, there you go. So yes, you just add real to real. So the first thing I'm gonna do here is goes 4 minus 5 just gives me a what? -1, exactly. And then 3 plus 7 gives me, yeah, plus 10. Don't forget the I, and that's done. It couldn't be simpler, right? But the thing is, now this is what we would call standard form, okay, of a complex number. I remember me saying that probably last semester a lot. Hey, don't forget, put this in standard form, okay? What is the difference between A and B? Are we kind of doing the same thing with just one little quirk? What is it?
Subtraction.
The subtraction. What do I gotta do with that guy?
Distribute it.
Yeah, distribute that guy in there. So are these behaving any differently
No.
than what we found from the real numbers? It's the same thing. We just got this little I. I would like to tell you, I is not a variable. Okay, I stands for imaginary. I is actually the square root of -1. If you really want to get to the truth of the matter. Okay, so remember that. Okay, so if I come in here, I can rewrite this as -2 plus 3i, but then negative and a negative make a positive, and then I get a negative again. And then once again, we're down to the same thing. -2 plus 5 gives me what? Just a 3, right? And then 3 minus 3, what happens?
I.
It's gone.
It's gone. Yeah, I get it. Yeah, but it goes to a 0, and you can say that. Fine, it goes to a 0, but 0 times I is always going to be 0. So this would end up being what? Just a pure real number. So just 3. Do the next one. See if you can remember it. I'll play catch up. Don't worry. I want to see if you can remember. Do not forget, though, what? Gotta be careful about this one.
The I squared is.
I squared is what?
-1.
Okay, there you go. So there's my little hint for you. Get you quick. Take longer. No,
Right slower.
was that?
I'm a right slower.
How was that so far? But what's the problem with that?
The I squared should turn to just a -6.
Right, I would take that, turn that to a -1. Negative and a positive, that would turn that guy into a negative, and then I can just get rid of that. Okay. Now what am I doing?
Find the 9 I.
Combine like terms, right? So I've got -6 minus 6.
-12.
Plus 5I.
Okay. Did you get it?
Yeah, I did. It's backwards, but.
Flip it. Always put the I on the right hand side. Has to be, because that's standard form. Because remember, that's the way the number is. If you look at them like a coordinate point, I got to do the real first and then I got to go up. Okay, or go down or whatever, but still, you do the X first and then you do the Y. But for us, for complex numbers, we do the real first and then we do the imaginary.
Okay.
Okay. If that always helped me in this class. What's going to help me is because in this class, we're going to do a lot of things. We're not there yet. Things are going to become very graph heavy. Okay. For me, that helped me understand a lot of this a lot better. When I could see a graph, I could almost see a picture in my head of the equation we're working on. And then I can go, oh, I see why this is behaving this certain way. Okay, that's me. The next one we won't do, but obviously you would have to do what? Can you distribute that 2 on the inside?
You write it twice and.
Yeah, write it twice. Okay. And then FOIL, or remember, that is also, if you are factoring, that is a perfect square trinomial, which means you have a formula for that of a squared plus or minus 2ab plus b squared. Okay, so you could just plug that whole thing into the formula, couldn't you? If you chose to. Okay, I could come in here and write 2 squared. Okay, I know there's going to be a minus next, times 2. Remember, this is my A, that's my B. Times another 2. Times a 3i. Plus 3i squared. Okay. You don't have to do it that way. Can you FOIL it?
Yeah.
Yeah, okay. But notice this turns into 4. 2 times 2 is 4. 4 times 3 is 12. So that's going to be minus 12i. And then I get over here, what I got? I got a 9i squared. But that turns into -1, which means that just turns into a -9. So 4 minus 9 is what? -5 minus 12i. So is it quicker than FOILing? It depends. I will say this, we'll be doing some that'll look like this eventually. Like I'm gonna put an X here. It'll have like a fifth. Okay, those are ugly, which is why I'm gonna end up showing you something called Pascal's triangle. It's literally just a little triangle you can make real fast or have it in your notes and just go, okay, when you do something to the 5th power, this is what it looks like. It's pretty neat, okay? A guy invented it hundreds and hundreds of years ago. So we won't do those very much though. So
Okay, how'd you get a -5?
4 minus 9. Because that positive 9 became a negative. That help you out? Okay.
Yeah.
Let's look at these right here. Simplify the following complex numbers, okay? Look at it carefully. Okay, first off, now we're simplifying. Notice this is a field. A field says I can multiply and I can add. Can't divide. Okay, so let's look at this very carefully. I'm going to bring this off over to the other side. And this is why we're learning about conjugates, okay? So a conjugate is anytime a given complex number a plus bi, the complex number a minus bi is called its conjugate. That works backwards as well. If you have a minus bi, the conjugate is a plus bi. It's always the opposite operator, okay? Once again, going back in time, if you were with me last semester in chapter 15, you learned about rationalization, okay? Where if you have a square root or any type of root on the bottom, you had to what? Multiply it by that and get it to the top, okay? We're doing the same thing. Remember, there's a square root at the bottom of this guy. I get it. You're going, no, there's not. There's I. Well, yeah, there is. That's a negative square root of -1. You can't have square roots on the bottom. You got to get them all up top. So this is what we're going to do. We're going to multiply everything by the conjugate. Okay? So walk with me down this path. 2 plus 3i all over 3 minus I. I'm going to multiply by the conjugate, which means I'm going to multiply by what? 3 plus I. But you're still in algebra, which means the rules will always be the rules. What you do to the bottom, you got to do to the top. Exactly. So you come over here and you put 3 plus I. Now, you can FOIL the bottom if you want to. But can you see what you just created?
Different.
Yes. Look, you have a squared minus b squared is equal to a plus b, a minus b. Well, can't I go, remember, when you have an equal sign, that means you can go either direction with those. If I have something of the factored form, can't I go backwards? Which means I can take this bottom part and go, well, don't I just have 3 squared minus I squared? Well, 3 squared is just going to become what? 9 minus, what's I squared? So that becomes -1, which basically in turn, this becomes what? A negative and a negative make a, so that's just 9 plus 1. And you have now gotten rid of any radical on the bottom. And you have a 10. But you're not done yet. You've still got to FOIL that whole top thing. Okay, so let's do that. So we have 2 plus 3i. And then we have 3 plus I. I'm going to draw my lines again like I will do as much as possible because, like I said, I don't want to get messed up and look at the wrong number. Coming here very carefully, 2 times 3 is going to be 6. 2 times I is going to be 2i. 3 times 3 is 9. That's going to give me 9i. And then 3 times 1 is 3. I times I, there's your I squared. Okay, so that's going to end up being a -1, which we can just say, hey,
-3.
that becomes a -3 there. Scratch that guy out. Now let's put it together. 6 minus 3 gives me 3. 2 plus 9 gives me 11. I all over 10. That will count as an answer, but I want you to be careful. If on a midterm or even in Hawks, if it says put it in standard form, that's not in standard form.
You want it separated?
It wants them separated. And remember earlier with the rationals, whenever I said, hey, if you get all these denominators, you can put them, since you all have the same denominator, you can put them under 1. Well, the same rule applies. You can take them and split them as well. And since 10 is a denominator for both of them, I can literally split this up into 3 over 10 plus 11 over 10i. And that would be standard form. This is also a good method to have if you're looking at trying to simplify those guys because they're weird fractions and stuff. Like when you get back to doing the quadratic formula later on, that's an easy way to factor it or to simplify it correctly. How about the next one? I got a few more minutes here. Anybody remember what a negative exponent does? Gonna be dealing with them a lot.
Put it on the bottom?
Exactly. Put it on the bottom. You're seeing a fraction here. Remember, a negative exponent takes something here and puts it on the bottom. Or on the contrary, or on the opposite, what happens if you have a negative exponent in the denominator?
Put it on the top.
Yeah, it goes to the numerator. Remember that? Okay. So I would need to rewrite this one into what?
4 minus 3i over 1.
Yeah, 1 over 4 minus 3i. Not over 1, we don't put over 1. 1 over, yeah. And we don't need that, anything else. And then once again, wouldn't we be multiplying by the conjugate again? Yeah, so I'll leave that for you to look up on your notes. Happy there? Feeling good about complexes again? Ish. Reason I bring them up is because they're just gonna show up now, guys. Okay, this isn't gonna be like, hey, let's review this and walk on like we did. They're everywhere. Okay, it's the reason we can solve everything is because of complex numbers. Okay, because for hundreds, literally, since the time of the Babylonians, I know this because I had to write a paper over it. They were trying to solve things and they couldn't. And yes, they had a form of the quadratic formula back then in 4500 BC. So if they could have done it with rocks, you can do it with calculator. Okay. But having said that, take it slow. Everything we're going to do in this class is going to harken back to something you learned in intermediate. Yeah, we're going to learn, come chapter 5 and stuff like that, we're going to learn some new things. And there's going to be some memorization. Okay. You're going to see that a lot of your midterm is going to be memorized. Okay, if you can memorize something, you're gonna be okay. Okay. Let's see, we need anything else here? Anything major? I'm gonna leave you to that one's a little bit weird. It's a fun one. Try it out. Don't go just jumping. Look at it carefully, you know. But then like play with it. It's in the notes, it's filled in, you know, it's kind of an ugly one. We won't run into those. I'm gonna be honest, guys. I took a complex analysis class and it was literally a math over the study of complex numbers. Okay, 16 weeks of me learning everything there is to know about complex numbers. And I never saw anything like this the whole time. So I just think sometimes in college algebra and algebra class, they're just mean. They're like, what's something we can make really, really ugly and try to scare people away from math? But I guess if you can do the hard stuff, then you earn the easy stuff later on. This one right here, remember, I to the 168th, that is why you have what? That formula there. Remember, divided by what?
4.
4, exactly. You take 168 divided by 4, and whatever, look for the remainder. Whatever the remainder is after that, find the remainder in one of these little sections right here and go, oh, okay, cool. I think that one is actually, it might actually be. Yeah, that's a 4 times 17. So notice you would come here and go 4 divided by 168 turns into 17. No remainder. If I come up here and look at the no remainder, I get, oh, well, that means that guy right there just goes to a 1. Okay. Anything else? Straightforward after that. Look at that. Nothing super ugly. That one might get you a little bit. Remember, rules of exponents still apply. When you look at this one, rewrite it. Okay. First off, don't forget. Okay, if you have you can also simplify that I to the -6. Okay, so look at that kind of stuff. Okay, because remember, you're seeing that negative I, you can also see -1 times I to the 6th. Okay, that will also, once again, do what? Simplify out. They're trying to trick you a little bit, so watch out for some of that kind of stuff. Okay. Any questions over today? All my notes are there. Well, they will be in about 4 or 5 hours. Once the like I said, today's lecture will be missing a little bit of stuff because you saw it on the board, you didn't see it on the deal, but all my notes will contain everything you did miss. Okay. Don't forget, please. The way homework is set up, 1, 3, 1, 4, 1, 5. That's due Monday. We come back. I'm going to hit things kind of hard and heavy. Like basically Monday, Tuesday, part of Wednesday, I'll get through 1, 6, 1, 7, 1, 8, 1, 9. And then we'll start next week's stuff. Okay. Now, if I have to, I'll start maneuvering stuff. But like I said, this is summer class. We go pretty quick. Okay. So where you see me skipping out on examples, know they're there in your notes. Okay. And then, of course, once again, do the practice, don't skip. And email me often. I'll see you guys later. And don't forget to do the attendance.